Alright, let's go ahead and get started on the notes part of things. So I'm going to walk you through 1, 2, and 3, and then we'll do number 4 as an example together. And then I will have you guys get started on the practice. The practice is homework. It's only 2 questions. One of them should be very straightforward. One of them will be a little bit more like the example I'm going to do for you. And so I'll let you guys work through that. So let's start off with what total energy is. So the symbol for total energy is a capital E, as you can see. And total energy is just the kinetic plus potential energy at any point of an object's motion. So this is at any one position in time, any one position in its motion. Its kinetic and potential at that point are its total energy when you add them together. Now, to be technical, it's any type of energy. It's not just kinetic and potential, but since we're dealing with mechanical energy, and those two in particular, that's what we're worried about here, is just the kinetic and just the potential. Now we'll get into adding work into this, but we're not ready for that yet. That'll be in part B of the notes. So, any point in an object's motion. So that's what total energy is. But total energy isn't actually all that useful. I'm never going to say, hey, how much total energy does an object have? That's not really useful. What's useful is using total energy for conservation of energy. And here's what the conservation of energy is. Conservation of energy says the total energy at point A equals the total energy at point B. It's very straightforward. If that sounds a lot like conservation of momentum, that's because it is. Conservation of momentum said that the total momentum of A plus B at the initial position is equal to the total momentum of A plus B at the final position. Same thing here. The total energy at position A and the total energy at position B have to be equal to each other. The reason I'm not using initial and final here is because it's not always the initial and final positions that we're using, and so therefore it's easier to just label the spots as A and B, because sometimes that initial and final can confuse people. Okay, so pretty straightforward as far as the setup goes. So let's get into things that you need to know when you're drawing diagrams. And I'm going to go ahead and draw the diagram for the example problem here, so that we can use that in what we're doing. So the example problem we're going to do is a roller coaster starting at the top of a hill and going to the top of a second hill. So the first hill is going to be 40 meters above the ground. The second hill is going to be, wow, that's a horrible 40. All right, well, there you go. Second one is 35 meters above the ground. So the first thing that you need to do all the time is you need to draw a picture. Obviously, you have to do that. I will not even begin to give you grades or points if you don't draw pictures. I have to see the pictures in order to give you any points on this, because everything you do on the work is dependent upon what you draw. And so if you don't show me what you draw, I have no way to grade the rest of it, because there's nothing for me to go back to. So start off by labeling A and B. So we're going to pick 2 points, and we're going to label one A and we're going to label one B. So how do I know what those 2 points are? So if you read the problem, it talks about the roller coaster starting at the top of a 40-meter hill. It goes through a valley and up to the top of the second hill. And then it asks for how fast is it going at the top of the second hill. So there's 3 points that it talks about. It talks about the top of the hill, the valley, and the top of the second hill. So how do I know which points to pick for A and B? Well, initial and final is a good starting point. You don't want to be held into those, but they're good starting points. It talks to me about the top of the first hill, so we'll call that A. And then while it mentions the valley, it doesn't give me any numbers for the valley, nor ask me to solve for anything for the valley. So instead of labeling that B, we're going to label the top of the second hill B, because that's what I want to know. I want to know how fast is it going at that point. So the first thing you need to do in your picture is you need to label A and B. The second thing you need to do in your picture is you need to label where your height equals 0. I need to know where the height of 0 is. And that may be very simple and just saying the ground is 0, and that's fine. But I need to know where that is. So make sure that you are doing that. Okay? So now that we've got that, we're going to label A and B. We're going to label the height of 0. We've got our picture drawn and set let's go ahead and jump into the example. So the example problem will follow next.